In today's video, we're going to be talking about special right triangles, and there's two types of special right triangles. The first one is an isosceles right triangle, which means it has two congruent sides and two congruent angles. And since all the angles in a triangle add up to 180, and we know it's a right triangle, so one of them is 90 degrees, the other two angles have to be 45, because 90 divided by 2 is 45 degrees. So here our first triangle, we said it's a right triangle, and the rule goes as follows. And you can find these rules on your formula chart that you get for the STAR test or the TAKS test. But the rules go as follows. Across from one 45-degree angle, we get x. Across from the other 45-degree angle, we also get x. And across from the 90-degree angle, we get x times the square root of 2. Okay, this is the rule that applies for any 45, 45, 90 triangle. Now the way I like to do it is I like to set up a smaller triangle because all 45, 45, 90 triangles are going to be similar to this one. And just to simplify things, I like to assume x equals 1. And if x equals 1, then with this 45, 45, 90 triangle, that means I'm going to have 1 here, and 1 times the square root of 2 is just the square root of 2. Okay? So every time I do 45, 45, 90 triangles, I like to draw this picture because every single one of my 45, 45, 90s is going to be similar to this triangle. Okay, so let's do a practice problem. Here, we know this is a 45, 45, 90 because if this is 45, that means this also has to be 45. And I know one of my sides, and I can use my rule triangle to help me solve for x and solve for y. So here's that rule triangle we talked about where we assumed that our x was 1. So we have 1, 1, and square root of 2. And now since we know these are similar, we can set up a proportion just like we did with similarity back in chapter 7. So I can say that 4 corresponds with 1, and that must be equal, let's solve for x first, x corresponds with square root of 2. So I can set up my proportion just like this. And now we cross multiply just like we did with any other ratios. So x times 1 is x, and 4 times the square root of 2 is 4 square root 2. So there's my answer. I now know that my hypotenuse is 4 times the square root of 2. Let's do the same thing for y. I know 4 corresponds with 1, so I'm going to set that up again. And that should be equal to y, which also corresponds with 1, so y over 1. When we cross multiply, I get 1 times y, which is y, and 4 times 1, which is 4. So here's my answer. Y equals 4. So just like that, by using this similar triangle, we were able to set up a proportion and solve for x and y. Let's do another example. Now this time, we know my hypotenuse, but I'm searching for my legs. Again, we know it's a 45, 45, 90, so I draw my rule triangle again. And we're going to set up our proportions. I know that 4 corresponds with the square root of 2, and that's going to be equal to x, which corresponds with 1, so x over 1. Cross multiply again, and I get x times the square root of 2 equals 4 times 1, which is 4. So we have this, but I want to get x by itself. So to move, since this is x times the square root of 2, to move the square root of 2, we're just going to divide. And when I divide by the square root of 2 on both sides, I get x equals 4 divided by the square root of 2. Now let's do the same thing with y. I know still that 4 corresponds with the square root of 2, and that's going to be equal to y over 1, because y corresponds with 1. And look, we have the exact same proportion that we did, because we know our legs are always going to be the same thing. So when I cross multiply, I get y times the square root of 2, which equals 4. And then when I divide by the square root of 2 on both sides, I get that same answer, 4 divided by the square root of 2. So this is how you do problems that involve 45, 45, 90 triangles. We have one more special right triangle, and that is the 30, 60, 90. And just like the 45, 45, 90, you will have a picture on your formula chart that looks like this. We have a right triangle, and across from the 30-degree angle, we get x. Across from the 60-degree angle, we get x times the square root of 3. And across from the 90-degree angle, we get 2x. So just like the last one, I want to set up something simpler. I'm going to assume x equals 1. And again, all 30, 60, 90 triangles are going to be similar to this triangle. So here's my 30, 60, 90. If I assume x equals 1, that means this is going to be 1. That means this is going to be 1 times the square root of 3, which is just the square root of 3. And that means this is going to be 2 times 1, which is 2. So now I can use this picture for any 30, 60, 90 triangle and be able to set up a proportion. So now let's do some practice. Here we have a 30, 60, 90 triangle. And now I draw my similar 30, 60, 90 rule triangle. And we're going to set up our proportion. So let's start with x. If I want to solve for x, I can set up the ratio 4 over 1 because those are corresponding. And I know that's going to be equal to x over 2 because those correspond. They're both hypotenuses. And when I cross multiply, I get 1 times x, which is x, and 2 times 4, which is 8. Boom, we're done. X equals 8. Now let's do the same thing with y. Again, I know 4 corresponds with 1, so I can set up that proportion, or that ratio, excuse me, and set it equal to y over the square root of 3 because those correspond. And when I cross multiply, I get y times 1, which is y, and 4 times the square root of 3. So y equals 4 times the square root of 3. Now we've solved for our leg and our hypotenuse. Let's do another 30, 60, 90 problem. This time, we don't know the hypotenuse. We're looking for the leg across from 30 and the hypotenuse. We know the leg across from 60, so it's going to be a little bit different. Again, we draw our rule triangle because we assumed x equals 1, so we get 1, square root of 3, and 2. And we know every 30, 60, 90 triangle is similar to this rule triangle. And we can set up our proportions again. This time, the one side we do know is the one across from 60. So 4 corresponds with the square root of 3. So I'm going to start with 4 over the square root of 3. And I'm going to set that equal to x over 1 because those correspond. When I cross multiply, I get x times the square root of 3 equals 4 times 1, which is just 4. Now to get x by itself, I got to get rid of the square root of 3. And since this is x times the square root of 3, I'm going to divide by the square root of 3 on both sides, which leaves me with x equals 4 divided by the square root of 3. And we're done for x. Now we can solve for y. Again, we know 4 corresponds with the square root of 3, so we're going to start our ratio with that. And we're going to set it equal to y over 2 because y corresponds with 2. When I cross multiply, I get y times the square root of 3. And I'm going to set that equal to 2 times 4, which is 8. Again, to get rid of the square root of 3, we're going to have to divide. Dividing on both sides leaves me with y equals 8 over the square root of 3. Now there's some other problems we'll do with special right triangles in class, but this is the basic strategy for how to solve problems involving 45, 45, 90, and 30, 60, 90.